So a binomial, you are already familiar with this. You probably just didn't know the terminology. Please fill in this definition. I've highlighted the key information. We are going to add some examples that I want us to create together. But a monomial is a number, a variable, or a product of a number and a variable. So it can just be a number, or it could just be a variable, or it could be a product of the number and variable. So fill in your definition for monomial. Okay, monomial is like one singular term. So remember, it could be a number. So like I could write it as 3, or I can write it as a variable. A number is a number, a variable. I could say maybe just x, or a product of number and variable. So what would I write as the product of this number and variable? If I product means, yeah, that would be just 3x. See how the 3 would be the coefficient in front of the x. Okay, now you can have more than one variable. You could have, well, that's with an exponent. So, but that is acceptable. I could also say 3x squared. What I mean by more than one variable, I could say maybe 5xy. So now we have 2 variables, but they're products, right? Product is anything where I'm showing written side by side. Okay, so your number could be a combination of variable, more than one variable, and a coefficient, the number. So the number doesn't necessarily have to be a whole number. Like, give me an example of another number, but that's not a whole number. 5.1. 5.1. Okay, we tend to do that as a fraction. So that one's not repeating. Give me another one. 2 over 3. Okay, so 2/3, that would be the number, the coefficient. Then I could have a variable. So I could have, let's say we do w instead of x, right? I could have more than one variable. Let's say I can have a t as well. And they could also have exponents. So I could say w squared and t to the 3rd. Okay, that's also an example of a binomial. A binomial is a number and a variable, a product of a number and variable. So that variable could have an exponent. I could just have the number, let's say, maybe a negative 5/3. Okay, that is still a binomial. It's just the one number, 5/3. Okay, now this is the part you should be already familiar with. Binomials with the same variable and same exponent are what we call like terms. So it has to, the key to this is it has to have the same variable, that's what I'm talking about, letter, and same exponent. Okay, so we are familiar with like terms. We have done like terms when solving equations. So whenever we're adding or subtracting binomials, you just basically combine like terms. Do not change the variable and exponent. That's very important. Do not change anything. So what you do, guys, you check your like term by checking the variable, the letter. Look at number 1. We have 17x minus 25x. They both have the letter x. Are they like terms? Yes, they are. So now we can actually subtract them. 17x minus 25x really is kind of like saying I'm going to just subtract the coefficient with 17 minus 25. You can use your calculator if you need to. 17 minus 25.
That's -8.
That's a -8. So our answer is -8x. You keep the variable. This is your final answer. All right, on number 2, -23y squared, there's the y squared, plus 6y squared. They're both the same letter and exponent, so now you can combine them. What would this be simplified to? Yeah, this would be a -17y squared. You keep the variable, you keep the exponent. just add the coefficient. All I did was add the number in front. So I said negative 23 plus 6 was the negative 17. And then I kept the variable and exponent. But guys, just make sure everything lines up. Make sure you're always using the same letters and exponents. So on 3, we have negative 15 a cubed bc, right? A cubed bc. It's the same. So now we just have to add the exponents. I'm just adding the negative 15 plus 6. When I do that, that becomes what? Negative 9 is my exponent, and then I keep the variable a cubed bc. Can they already be simplified? Yeah, that sometimes can happen, yes. Well, it can't be simplified more. On 5, what's wrong with 5? So here we have AB, and then if I look, I have AC. Those are different variables. They're a different product of variables. So basically what they're showing you here is that you do not have, they're not like terms. So if you do not have like terms, you cannot combine them. So this is your answer, basically. This is the answer. It is already simplified. You would keep it as that. All right, on 4, my variable is x squared y, and then I have an x squared y. We're going to subtract them. So if I have a 38 coefficient here, you remember what happens when you don't see a number? It's just a 1. There we go. It's just a 1. Okay, so this equals what? 38x squared y minus x squared y will leave you with
37.
Yeah, 37, which is our coefficient, and then x squared y. Yes, you keep the same letter product, okay? All right, so what does 6 get simplified to? If I have a negative mn plus a negative 8mn, 8's the coefficient, plus 9mn. Yeah, we would say 1mn, okay? But that's the same thing as just saying mn, okay? If you put 1mn, it's the same thing as just mn, okay? All right, I want to talk about one more before I check your understanding here, okay? All right, let's look at 7. Do you see we have 2/5 CD squared minus 1/3 CD squared? Okay, so guys, you see we have the same variable combination, same product of variables. So they are like terms, okay? So when we have fractions, you have to find the common denominator. That's right, okay? In order to add this, we need them to have a common denominator. What's the common denominator between 5 and 3?
15.
15. Okay, so that's gonna make this, should I put it underneath? Yeah, I'm gonna put it underneath. 15 is on the bottom. So what would I have to do to the denominator 5 to make it a 15?
Multiplied by 3.
Multiply it by 3. So you have to multiply by 3, so this becomes 6/15, and you keep the variable combination, CD squared. Then what would I have to do to 3 to make it a 15?
You multiply times 5.
Times 5, so that becomes times 5 to the top. 5/15, right? With the same CD squared. So now I can combine them. If I have 6/15 minus 5/15, what does that leave me? 1/15 CD squared. Okay, if you were not good with the fractions, guys, go to your calculator, please. Everyone, get a calculator, clear it out, get to a blank screen. Get a calculator, please. Does anyone remember how to make a fraction?
You divide it by one.
Oh, no, there's an actual, I can put fractions in the calculator.
F1.
Huh?
F1.
F1? Okay, how do I get to F1? You're right. F1 is right here. I don't know if y'all saw it, but Dylan's right. There's F1 right here. It is green. So what does that mean I have to hit?
Press alpha, Y.
Alpha, then Y equals. See if you get this on your screen.
Yeah, I got that.
Okay, so we're going to pick the fraction with just a numerator and denominator. Okay? The second one is a mixed number. So we're going to just pick number one. You can type in the number one, or you can just hit enter, and you're going to get a fraction box. Okay? Our fraction box tells us what numbers we're going to put as our numerator and our denominator. We had 2/5, so we arrow down, put a 5 at the bottom, then arrow to the right to do the operation. 2 on the top, 5 at the bottom, arrow to the right. 2/5, we're going to add that to, no, I'm sorry, we're going to subtract that from, so minus 1/3. So I do alpha, Y equals again, hit enter to get my fraction box. 1 is in my numerator on the top box. I arrow down. I put the 3 at the bottom box. I arrow to the right. So if you're not good with adding and subtracting fractions, you can use the fraction option in your calculator. Once you have it typed in, hit enter, and there it is, 1/15. But here's the thing, guys. You have to remember these keystrokes. No one can tell them for you. Like, once we start learning more keystrokes, you have to remember them, because I cannot start telling them to you on tests. No one can tell you on STAR. No one can tell you on PSAT. You have to do it your own. Okay? All right, so this can help you if you're not strong with fractions. All right, we are on number 8. Okay? Are they like terms? If I look at my variables, x to the 4th, y to the 3rd, x to the 4th, y to the 3rd, we're good. All right, what is a negative 25 minus 25?
Negative.
Yep, so our answer would be negative 50 coefficient, x to the 4th, y to the 3rd. Are we okay on that? All right, jump to number 15 for me. Okay. 15 says subtract 9a from a negative 15a. How would that be written?
Negative 15A minus 9.
Very good. Okay, so make sure we're writing it, we're setting it up correctly, so we have the correct sum or difference. Now, on 14, it says the difference of 10x squared y and 2x squared y. How would we write this one? Because this is the difference of, yeah, 10x squared y minus 2x squared y. Yes. So when it's subtracted from, you have to change your order. That's important. When it's difference, you do not. Does anyone see that? Okay, so in class right now, I want you to finish 9 through 16. I'm going to come by and stamp this page. When you're done, I'll have the notes for the next section up for you to add. Okay.